So looking at log laws, which is the next step now in being able to graph our log and exponential graphs, we need to be able to work with these equations. And one of the most important things in working with these equations is to be able to go from log form to exponential form without really even thinking. So we're looking at this over here as an example, or that's the generic. I always think of 10 to the power of 2 is equal to 100. So 10 to the power of 2 equals 100 is in exponential form. In log form, it's log base 10 of 100 is equal to 2. So moving backwards and forwards between these two has to be very, very natural to you. So a to the power of 0 equals 1. Writing that in log form, log base a of 1 equals 0. A to the power of 1 equals a, log base a of a is equal to 1. They're probably two really good ones just to know straight off the tip of your tongue. So moving backwards and forwards is really important. The other thing is knowing all of the log laws. So let's start with this one here. Again, you should see some parallels with the index laws that we've just been looking at. So log base a of m times n is equal to log base a of m plus log base a of n. Really important that if you're going back the other way that the bases are the same. We must be dealing with the same bases. The next one, when you are dividing, so log base a of m over n is log base a of m minus log base a of n. This third one, log base a of 1 on n is equal to log base a of 1 minus log base a of n, which is equal to negative log base a of n. Really, we can, once we have a look at this rule here, I'll show you another way of doing that one. So when you have a power, log base a of n to the power of m, that power can move down the front and then you end up with that. So in order to do this one differently, that would have been log base a of n to the minus 1, and so therefore we can bring that minus 1 in front. Alright, and you don't write the minus, it just becomes minus log base a of n. So the manipulation of these rules is really, really important. Again, it's going to help us when we are finding intercepts and information for our graphs. So trying to get these expressions in their most simplest form, we're going to be using our rules. And again, we need to be able to use them backwards and forwards. So if I'm looking at this one, I'm thinking about my rule where that if I multiply log base a of mn, it becomes plus. Or going back the other way, this would be log base 10 and 5 times 2 inside the bracket, which of course is 10. And when you have this situation where the number and the base are the same, log base 10 of 10 is always going to be equal to 1. So log base a of a is equal to 1. So that's that expression simplified. It becomes easier the more you practice them. Okay, we see subtraction of two logs here, so and they are the same base, always check that. So it's 20 divided by 5, and of course same things happening here. Log base 4 of 4, we have the same base, so 4 and 4, which ends up being 1. Next one, log base 2 of 16. What I would always try and do is see if I can write the expression with a base of 2. So 2 to the power of 4 is equal to 16. And we know from our rules that you can bring the 4 down in front because it's a power. and I've got log base 2 of 2, which is 1. And so I get 4 times 1, which is equal to 4. Again, the more you practice, the easier it becomes. The next one here. So again, I'm going to try get the same bases here. So log base 3. Now, 3 would be ideal, and I know that 3 to the power of 3 is 27, plus log base 3 of 3 squared minus log base 3 of 3 to the power of 4. So bringing down those powers now, you get 3 log base 3 of 3 plus 2 log base 3 of 3 minus 4 log base 3 of 3. And hopefully you can see that that's 3 times 1, which is 3, 2 times 1, which is 2, 4 times 1, which is 4. And tidying that up, 3 plus 2 is 5, take away 4 is 1. So if you keep your eye on the rules that we looked at initially and manipulate them backwards and forwards, you should be able to work through exercise 13E.